Assalamu alaikum, dear students. It's me, Muhammad Zubair Khan, and this is the fifth week. And today we will discuss the next topic that we have in the course outline of Mathematics 2 for BBA students. And the topic is limit of a function. If you remember previous topics, we discussed the function, the types of functions in which we had discussed the total cost, total revenue, or total profit functions, and we have solved few questions related to these three types of functions. That was the practical application of the function. Now we will discuss the limit of a function in this particular video. I will try to explain the limit of the function, and then I will try to evaluate the limit of the function, how to evaluate the value of the function or the limit of the function. So first you need to understand what is meant by the limit of the function. So it's very much clear in the definition that a limit of a function is the value that functions approaches as the independent variable of the function's approaches a given value. It means that the value of the function totally depends on the independent variable of the function. So if the independent variable of the function is approaches towards a specific value, so the function automatically approaches towards that particular value. That is basically the definition of a function, and it's very much clear in the definition that a limit of a function is the value. It means that the limit of the function is also a value. When you are finding the limit of the function, so you will get a value of the function. Okay, so a limit of a function is the value that function approaches as the independent variable of the function approaches. The independent variable, normally we are using x as an independent variable, so it means that the x approaches towards a specific value will lead the function to approach towards a specific value. It means the value of the function depends on the limit of the function, or the limit of the value of the independent variable. Now mathematically we have the form like this: limit lim, representing the limit, x tends to c, or you can say x approaches c. X approaches c. F of x is a function, so it's giving us a value t, is equivalent to the statement that limit of f as x goes to c is t. It means that when we are applying, this statement basically means that when we are applying a limit on a function, so the function approach towards what? T, but with respect to a specific value of x, that is c. For example, if we have a function f of x, that was the general form, that's why it's not very much easy to understand directly, but it will take time when you will solve the questions related to these limits and continuity. Then you will be able to understand that what is meant by limit, how we can calculate the limit, or how we can find out or evaluate the limit, and how we can understand that what is the continuity and what is discontinuity, how to understand the continuous function and discontinuous function also. Here we have an example like this: f of x equal to 3x, limit x tends to 2. If x approaches to 2, so what will be the value of f of x? So it's very much clear. Look at limit x tends to 2, f of x equal to 3x. Now if we apply the limits, so after the implementation of the limits, we will get 3 into 2, which is equal to what? 6. It means just only replace the value of x in the given function, so you can get the value of the function, which will be known as evaluating of the function. Evaluating of the function, or finding the limit of the function. So the limit of a function is 6 if x approaches 2. If x going towards 2, So the function will approach towards 6. Now, in the next video, I will solve few questions related to the evaluating of the value of the function, but or evaluating of the limit. But let me discuss few properties that which are very much important to understand, because we will face these properties directly. You can apply the limit sometimes, and sometimes you are applying the indirect limit. Indirect limit means first you are needs to simplify the given function and then apply the limits, because direct implementation of the limit is not suitable or not giving you the proper result or a solid value. But before to evaluate the values of the function, before to evaluate the limits of the function, let me describe or let me explain the properties that we have in the function. For example, if we have two functions, one is f of x and another is g of x. And if we have a limit x tends to a, or limit x approaches a, so this limit will be the limit of both the function. Limit x tends to a f of x plus minus limit x tends to a g of x. It means in case of addition or subtraction, if we have more than one terms, this is basically related to the expression or the polynomials. If we have multinomial equation or function, so we can apply limits on each term. We can apply limits on each term of that particular function. So limit as a whole of the addition or subtraction of two function is limit of each of these function. Limit x tends to a f of x plus minus limit x tends to a g of x. The next property is if they are in multiplied form. If two functions are in multiplied form and having the same limit, so this limit will be the limit of both the function like the previous one. Limit x tends to a f of x multiplied by g of x. So we can say limit x tends to a f of x multiplied by limit x tends to a g of x. Separately we can take in case of addition, subtraction, in case of multiplication, as well as in the third rule or the third property, in case of division you can also apply the same limit. So limit x tends to a f of x divided by g of x. So this limit is the limit of numerator as well as the limit of denominator. The next one is if we have a constant number in multiplied form with the variable. So constant number will remain unchanged and the limit will be applied on that particular variable. For example, limit x tends to a k f of x. So k will remain unchanged and limit will be applied on the function like we did in the example. If you see here we had 3, but we didn't change 3 with any other value. 3 remained unchanged and we just apply limit on x, that becomes 2, and then 2 multiplied by 3 gave us 6. So limit x tends to a k f of x is equal to k into limit x tends to a f of x, means that limit will not apply on a constant function. Then limit x tends to a f of x whole power p, suppose if we have any power, so we will apply limit inside the power and the power will remain unchanged. Limit x tends to a f of x whole power p. It means this limit will be applied inside the power and the power will remain unchanged. And the last one is limit x tends to a and k is equal to k. If we have a constant function, for example, limit x tends to 2, and if we have f of x equal to suppose 5, this is a constant function, and if we apply the limit, so we will get the value of the function is 5. It will not change, it will not affect by the limit, because there is no independent variable. So if there is no independent variable, it means we cannot apply the limits. So by using these properties and some other rules, we can evaluate the limit of the function. First, you need to understand the definition of the limit of a function. Then, you need to understand that which properties will lead you to find out or to evaluate the function. So, in next class, I will evaluate the functions by solving different examples. Thank you very much. Allah Hafiz.